Hello everyone, my name is Borja. I am project director, I'm an architect at IDOM. Here my colleague Sergio, which is part of the project that we're going to talk today about. So what we are is a firm on architecture, consulting and engineering, and we're an independent firm. And in this case, what we are going to talk about here is a full commission that we got to design this building, winery in La Rioja, in Spain, where there's the big Spanish wine coming from, for our client, which is BERONIA, a very well-known in the world wine production. Good evening, how are you doing? So what I think is interesting of this is that today we're not going to talk about HVAC here, we're not going to talk about systems, we're not even going to talk about architecture, but we're going to talk about how to approach a building from all those variables within a process in which they are all together. And all the people that is working in there is part of that design and is part of that way of thinking. So, if this works, here we are. Well, so when we got this commission, what we first did is went to the place and see how they have done this for tons of years. And what they used to do there in the north of Spain is they used to set, here you see the, let's say these bolts beneath earth, let's say 6 or 7 meters beneath earth, where they set there the barrels for wine. And it's pretty smart. Down here you have around 16, 15 degrees of temperature, as they said, and it has almost this appearance. As you can see here, they have sort of these chimneys to introduce air. As through the process of fermentation of wine, CO2 is produced, and there you get out of oxygen, you run out of oxygen in there. So what did they have usually? They have a little house, what is the social place, where they live, where they gather. In this little house, they have where they press the wine with their feet. This wine gets into these barrels, and then it goes down through gravity to the places where they're stored, and the wine matures a long time, right? Super smart, super easy. What else we learned when we went there? Look at this. This is a village close to which we were asked to design the winery. And all of these brown marks are the different wineries down earth. This is the buried surface underneath earth. So it was a whole reality underneath earth that you cannot see. You see those beautiful houses up there, and all those that are wineries that are happening and now those cellars, right? And you see they are oriented northeast, super smart, and no contact with the exterior. So these people spend October, November working underneath there, here, no lights, temperature is constant, 16 degrees, wine is perfect. It's sort of a big gap between what they did have in the 60s, 19th century, right? What we have now. And if you see this, what's happening in all the villages around the site that we have. In this site, there is actually a production winery, which is this one, which is from 1972, more or less, right? And the concept has already completely changed. This is a conventional production industry, above earth. The cellars are beneath this, but most of the surface is above earth. A very interesting wine cellar production in terms of technology. And what they asked us is to design a new one within this site that had some relationship with this one, as this one is working very well in terms of function. It's perfect. So what was the challenge here? They asked us to make something that was representative in terms of architecture in this place, that it was representative in terms of winemaking, what is the future of winemaking, and that it was integrated in the landscape, plus it was a reference in sustainability, right? So when we arrive here and you get to see this beautiful landscape, this is the actual winery that you were seeing. This is the one here, right? This is what we find in this landscape. This is this little difference here in level, which is 8 meters in height, and these beautiful vineyards and these mountains there. So it was like, wow, I don't want to touch this place. Come on, never put that there. So that was a competition actually before we got the commission. So what we did is set our winery within this space here, this 8-meter difference between the top and the space down here. And we set out some objectives that we thought it was, let's say, breaking through what wineries were used to be. First, we wanted people to work there with natural light in a winery. Well, they went crazy when we told them, wow, natural light, how are you going to put natural light into a winery, right? Second, we wanted to work through gravity. We wanted to do what was already done a lot of years ago, and it worked very well. Let's put the grapes from the top, let them go into the presses, let's press it, and then go into the, let's say, tanks, and then into the barrels, and then into the bottles. So one and another and another and another. So when we saw this, let's say there's 8 meters in here. It's almost there. So if we set ourselves in this difference of level that we're seeing here, we're almost there. And another thinking that came from the place, it was this sort of formations like in half moon shape, which are very interesting. And now I'll tell you why. So here we are, ready to set our winery and thinking how we can put all that things together. Very important also, and there was Sergio and sustainability team, we were on the same table, is inertia. One of the things that worked perfect of burning those barrels 6 meters underneath earth is that the temperature is constant all the time. So how are we going to keep that with a production winery that needs to produce 100,000 boxes of wine, which is not the same scale, right? So let's say we were thinking, well, there's a relationship because this terrain goes up and down. So we're gonna see this towering here, but we're gonna have some independence in this place, which is very nice. So both of them are related, but this is a new one. The other thing is going up and down and having this 8 difference here in height will allow us to work through gravity, and I will see how. And then the other very interesting one is we have these views and the opportunity of having lights where we need it. So a very important issue is here, and this is an exercise we did through competition. This is actually the building that they have. So first question is, can you bury this volume? Thinking that this is not a superstar building, this is something that needs to be productive, and the price of this building should be in the range of a normal winery. It's not that we have here a spectacular amount of money. But we did the exercise during the competition and say, all right, if we don't bury it, then we have 60,000 cubic meters of air that we need to control climatically. We need to control the temperature of this. But if we bury that, then our facade that is exposed to the exterior is just 800 square meters through against 4,000 if it was above earth, right? So it's obvious that if I bury it, I have less contact with the air and I am absolutely protected, right? But I cannot go very deep inside because the deeper I go, the more earth I have on it. The structure suffers a lot. I need to pay a lot of money in structure. For this size, this is 180 meters length, I cannot build a bolt in each one of this because it would be huge bolts, right? So I need to make have a compromise in between the depth of the wineries when it's buried against the structural system that I need to support that earth. And that's a big question, and how we did that and control the temperature is something we'll explain right now. So how did it work in terms, once I put the winery here? We take advantage of the situation. I'm gonna go now and talk a little bit about lights. So what we did is set the visits in front of the production, so you were walking on top of the terrain, walk above the production, and all your communication is going to happen on the facade, right? So this element, whatever we build here, is going to be a filter that is going to let us control the light and radiation entering into the production area, right? This is pretty abstract. Let's see how we've done that, right? And another thing is, if you set up the different parts in the process of a wine-making industry, not all of them have to be protected from light. Some of them can have light, and it's nice to be working with light. Some of them needs a little light, and some of them have to be absolutely without light. So if we set this social area in the upper part of the building, we can use a different section to control the entry of light, right? This is sort of how it was in competition. We built a green roof above it. We have on top of this level, let's say the social area, right, where you have this the wine store, and you have a sort of a multi-use rooms and some place where to taste the wine. And if you can see, that is above. This is the barrels here. This is the tanks, and there's nothing that you can see down there. So if you go underneath, as I was saying, the grapes will drop here, and then they will go through gravity. Here you have tanks. This thing is gray here. This is a terrain. So the whole three spaces, which is tanks, barrels, and bottles, were completely buried in the part that is behind them, right? And covered with 1 meter of soil, just 1 meter, right? See, as here you see production, barrels and bottles. How this works is the grapes come here, from here they go to the top of the tanks, from the top of the tanks they go to the press, and from the press you take it to the barrels. And that's almost like and from the barrels, then you take the barrel here, you put it into bottles, and you keep them on there the time that you need, 2, 4, 5 years. These wines are going to be the reservas and grande reservas, which are the ones that stay more time in barrel and bottle. Right, so there's a big space for keeping barrels and bottles. And these spaces need to be controlled in terms of temperature and humidity the whole year, and they need to be super stable, right? Well, so we took advantage of that situation now here in the barrels, and you see how the section along the building is changing. This moon shape that we have allowed us, or we use it, to set the spaces depending on the amount of light and radiation that it was, let's say, sustainable to let in, right? So, production, which is where the tanks are, this one is oriented southeast. The production is the one in which we have these big tanks. These big tanks are actually have their a series of sleeves where you put cold on or warm water, depending on the process of fermentation that you want to do. So it is valid to have their natural light. It's great, you can have it. And what we've done to control that in this space, which is 8 meters high, is to have a big cantilever, 4 or 5 meters, in this moon shape that is going to be shading it along most part of the year. But in the morning and in the evening, in which we have a series of how you say that? Shades, of window shades that are automatic, and they move up and down. Barrels need to have super little light. So what we did is we set, as you've seen in the image, the social part above it, and there's just a little part of diffuse light that enters and gives some light inside there. And finally, the bottles will have no light, and they're actually buried in here. And you have this 1 meter of soil above and completely covered around it in both cases. Right, so how you arrive to this place? What happens related to all these thoughts and putting together? So as you see, guys, what we're doing here is we're designing a building, introducing all the concepts as a matter of design. So we've buried it, we've separated each of the parts depending on the amount of energy that they can take. We have covered them with these green roofs, so we can control the amount of radiation through those green roofs. There's some issues that you don't know yet how we control temperature, right? Not yet. And what we have now is sort of a green cover up here and three big spaces underneath Earth there. And that gives us a very interesting experience when you arrive. As I told you, there's a little mountain here, so when you walk up, you see nothing. You get inside those vineyards, you have no perception of what is happening but the vineyards. So you forget about what you were thinking when you arrived here. And suddenly you see the upper part, which is the social area, because all of the rest is buried underneath the vineyards. 1 meter of soil is just enough, more than enough actually, to have grapes, vineyards with great grapes. And in the case of the ones that are going to be just above the production area, those are the ones that they keep with more by hand, and they take a lot of care of them. So it's even a place where you can go when you're coming into the building and take some grapes and taste them before you enter into the winery. Where you can see here, when you go through the first phase, you can see here how this moon shape changes the orientation of the facade. So for each orientation, we have set a different space that allows a different kind of energy entrance, let's say. Right? Here you're seeing where the barrels are going to be. You're seeing here the social area, and you're seeing this cantilever of 4 or 5 meters, depending on the area, that is protecting the entrance of the sun. And again, you're here in between the vineyards in the upper part and the vineyards in the down part here, and you see how we're working out the diffuse light, which allows us to enter a lot of light in the social area that barely needs to be illuminated with LEDs, and in the production area. These are some images of the competition. You see how we're working lighting in here, how we're working this experience. This is amazing. I mean, you don't have a winery in which you're actually working in the vineyards, right? And how is it? This is how you see it now during construction. And this again from the social area. You see the barrels, you see cantilever, right? And here you see the experience of natural light entering in the production area. And they spend some time here, and this is this big moon-shaped roof. Here you see it again, and this experience with this difference in topography that changes the section in between. Here's where the bottles are, where the barrels are, or where the tanks are. So sort of the proper terrain is helping us change the amount of light of that section that is changing along the whole facade. And now to understand.
I can continue.
Yeah. There you are.
Okay. Now I will continue talking about the climate comfort, how we have achieved the climate comfort in the cellar, in the wine cellar. The first picture, you can see here how is the climate today in La Rioja, in the north of Spain. As you can see, we have kind of mild winters and hot summers, but I mean not really so hot. We change between 5 degrees to 25 average temperatures during the whole year. And we have done a study about how can be the resilience to climate change. There you can see the scenarios that we can face in the next years until 2100. And the best scenarios, we will have an increase about 2 degrees in the best one, and the worst one will be around 6 degrees temperatures degrees Celsius. So, and in this picture you can see the same with the current scenario and the future scenario with this 6 degrees worst scenario case. So as Borja said, that we have decided is to use a system that is as passive as possible and to try to replicate what has been used for centuries in La Rioja. So trying to vary it as much as possible, and the areas that are not varied, that is not so varied as normally, which is this upper slab. We are going to use a tap system, which is a thermal activated structural system, combined with a geoenergy system. So here we talk a little bit about how the ground temperature is in this location. We have done a thermal response test, and on the left side you can see in which how normally how it's actually working in this place. So in the first 3 meters, you will have temperatures that are around the average monthly temperatures. So you will have around 23 degrees during the summertime and 6 degrees during winter time. And when you go down to 10 meters and below, the temperatures are around the same as the annual temperatures of the place. So we can use this characteristic to get a good comfort in the cellar. So there you can see the thermal response test that we actually have done there in the place. We have temperatures, constant temperatures around 15.5 degrees all year round. And there the results of the ground conductivity, borehole thermal resistance, and undisturbed 1 ground temperature. Let me see. What we have done, we have replicated the building in a 3D simulation program called Design Builder. So we actually have all the external conditions that from the local climate of La Rioja, with also all the solar shadings and all the characteristics, even with the HVAC system in the program. So we can really replicate the thermal conditions inside. Yes, and in this picture, we speak a little bit more in detail about what Borja said before. This is the HVAC scope. So you can see on the left side, you can see the 3 main rooms for the wine production. So the first one is the one where we have the lax deposits, where we have a double layer with water circulating in between. In this area, the ventilation is just to control the high levels of CO2 that are produced by the fermentation. So when the levels achieve 3,000 ppm, the fans starts working and increase the levels. In the second one, this is the barrel area, and this area we have this tap system in the ceiling, because in the ceiling we have just this 1 meter depth of soil, so we still get external loads from the outside. So in order to block these external loads, we introduce these taps, which are pipes with water circulating at 16, 15 degrees and keeping the air temperature inside constantly. And also another point there is we need to keep the humidity always under 75%. So we have also a direct expansion system to control the humidity all year round. And the third one is the bottles depot and the bottling process. No? So in the bottling process, we just have sanitary ventilation, and there we use a lot of hot water that we are producing in the thermal panels on the roofs. And in the bottle area, we are using also this tap sealing to also block these external loads that we can get, and also the dehumidification to keep under 75 relative humidity all year round. And then in the floor above, this is more like a social area, and it's a kind of a standard, like it could be in an office, where we want also to keep with the taps, using the taps in the floor and in the ceiling, a very passive system, keeping temperatures constantly all year round, and combine this with an HVAC, with demand control ventilation with CO2 sensors all year. And in this area also we are using power induction units, because there it will be more like we have some meeting rooms that will change a lot the amount of people there, so we need some specific units for these areas. Yes. Yeah, there is a section where you can see what I have already explained. It is important to say that we have divided the system in 2 different groups. One is called the free cooling system, with 6 boreholes that are providing free cooling to these 3 wine production rooms. And then we have another 6 boreholes that are giving comfort to the rest of the areas, combined with heat pumps that I will show now in the flow diagram. Let's see. In the next one. Yeah, here you can see what I have already explained. On the left side, you can see the upper slab, the concrete slab, with the taps that are with these pipes inside, and then you have an insulation layer, and then you have the 1 meter soil. So we are blocking all of these external loads from outside. And here you can see a representation of the taps in two of in the barrel area and in the bottle area. And this shows a representation of how can work a geotap that is using the thermal mass to compensate the winter and the summer loads during the whole year. The important thing is to dimension the system, so in the same date, when past 1 year, the difference in the temperature of the soil, it can be no more than 0.2 degrees. If you get more difference, then the system will be unbalanced and will start not working. So we need to have constant temperature around the year in the ground. Now for this, we need to size properly from the beginning. When we did the simulations, the first ones that we did the simulations without the taps. And you can see there that we have the 3 diagrams there, and none of them actually achieve what we want. You can see these lines here. They are showing the set points that we want to get between 14 to 16 degrees. And when we are actually getting, we are going out of the set point in the average one here. We are going out, but here in the summertime, we are far away from where we want. We want to be here, and this is the summer, and the winter is the same. We are also far away from where we want to go. So when we did the next simulation with the taps, these are the taps. Installing the prefabricated concrete. Yes. And these are how they are distributed. You have 6 boreholes for the free cooling area with the production wine, and 6 boreholes for the comfort area. Okay, and now here I will show after the next simulation, but here you can see how is the operation scheduled for the whole complex. So you have the wine taps that are for the barrels and the bottle areas that are working day mode and night mode, and actually as a base are working with free cooling, just with the circulation pump, circulating the water from the boreholes, and the geothermal heat pumps are actually not working. They are just working when we have really peak loads, where we cannot really compensate, and this will be very, very few hours per year. And the comfort taps, they are not working with these 6 boreholes, they are working with the 6 boreholes that are together with the heat pumps, and the same with the air handling units and the power induction units. So we have like 2 groups. The first one, it will try always to work with the free cooling boreholes to keep the temperature as low as possible. Yeah, and this is the schematic. That is what I explained before. This is the free cooling with the 6 boreholes for the wine production, and this is the other 6 boreholes for the rest. That is the comfort areas with their handling units, and these small rooms, meeting rooms, and so on. And this is divided by each one. So you have the free cooling. We have 6 boreholes that are producing 40 kilowatts free cooling, 1,300 liters per hour. And the next one, that is the 6 boreholes working together with the 2 heat pumps in normal use. And when we don't reach enough power, we also connect this with the other system, with the free cooling system. But this is just a very few hours. We try to avoid this situation. And these are the results with the design builder simulation here. This is the simulation that I showed you before with the diagram, where we cannot meet the goals. So this is the situation without the taps. And you can see that the average it's around okay. We are in 16 degrees on average, but it's quite dispersed in temperature. So it's working, but it's not ideal. So you have there the hours that are outside the set point, that are around 3,500 hours out of the 8,760 per year. And this is what happens with taps like magic. So it changed a lot, as you can see, and with very, very low operation cost. So out of this 8,760, we just have literally more than 300 hours that we are outside the set point. And actually these 300 hours are just 16.5 degrees. So it's negligible. So we say 100% sure that we are achieving our goal with very, very low operational cost and environmental cost with these taps. And this is the scenario where we have 6 degrees more in temperature and without taps. And you can see that the situation is quite unstable and achieves temperature up to 22 degrees, which is not acceptable for wine production. So, and if we consider the taps, this is a situation that can be 100% okay. We are achieving some hours are outside the set point, but are very, very few hours if you compare with the total amount. Yes. And this is the last slide. That is the conclusion. So the first conclusion will be like the taps in free cooling mode. We are using 20 out of this 68 kilowatt that we have available, and this 20 is exactly what we have. No, it's not exactly. It's less, but it's 100% free cooling. So we are not using something else than free cooling. And this can neutralize the external loads while reaching the design temperatures in the wine storage warehouse. And it creates the thermal behavior in this spaces similar what they will be. We have 100% barrel with much deeper situation with the slab. It will be in a deeper position. The second is connected with the climate change, that if we take the worst scenario with this increased temperature of 6 degrees, we can see that these taps control the main part of these external loads without any problem. And as the last point, we can say that the installation of these taps is the right thing to do, and we need to work with the operation, with the correct operation with these taps. And the life it will perfectly work during the whole lifespan of the building in all of the studied situations that we have now. So we really believe that it's the best choice for our client. And yeah, I don't know, you want to add something?
No, if you have any questions, I just rather discuss.
Thank you very much. Any questions?
What is the payback period comparing to a normal solution, let's say, without geothermal and so on? Because it should be high cost. The second question:
the investment cost is high, but the operational cost is extremely low.
That's why.
So the payback time in a geothermal system is less than we can say 8 years, less than that, I would say. Yeah, because you compare also this. Well, firstly, if you do an active standard system, the comfort that you get is not as good as this one. So you already have an additional problem. But even like that, comparing, if you speak about just numbers, it's less than 10 years. It's like 6-8 years.
You use natural lighting as much as possible. You use air circulation. I think where you didn't go for the passive house standards. Is it close to those standards or not?
I think, regarding, we were talking about this, about infiltration, and we have control about infiltration, about thermal breaches also, and about insulation. I haven't checked, but I think that we are quite close to these standards.
Yeah.
But you have to think also that the energy that we consume in this building, a lot of is process energy. So it's not connected with the envelope, really.
Yeah.
But everything that is connected with the envelope, it goes down to the minimum that it can be.
Yeah, just saying because the winery owner maybe the certified with LEED or.
This
Yes.
is LEED certified.
Yeah,
it is.
This is LEED certified. Yeah. So. Yeah, and also the whole ventilation system we have with thermal wind with heat recovery. So.
Can I ask the
Sure.
boreholes? Are they close?
There are 8 meters in between.
8 meters in between?
Yes, there are 2 lines of boreholes if you go backwards, and they're separated per 30 meters, 2 lines, and 8 meters in between.
Yeah.
So there's 2 lines here. This is production. This is under the production where the tanks are. So this one are 8 meters in between each one, and this is 30 meters more or less.
And we have done a simulation with energy air design. I mean, a software that controls. We have checked the temperatures, how changed after 20 years, and it's completely balanced. The
You
system.
mean external temperature?
Yeah. So yeah, we have checked it also with the change in temperature.
Yeah, that's interesting.
Yes.
How many years lifespan for the building you calculated? 60, 80 years?
Yes.
Something like that.
Yes,
I don't
like that,
remember.
something like that. The big issue here in terms of deciding what system you use, I mean, the big decision was to bury the building. You can, one of these buildings, you can keep them above earth as you do conventional production centers. The decision to make it beneath earth, the big cost was not the taps, was to make all the earth movement and put it inside there. Once you got that, the inertia is that big and the temperature is that positive for you that the installation is much cheaper than if you do it above earth. So it's not just at the return, but what you're not investing at the beginning. You have to make a climatize or air condition 60,000 cubic meters of air to keep it at 17 degrees. That was a big issue.
Yeah, when you have outside 30 degrees.
30,
several-
35, 40.
So,
Is the building built at the moment?
It is under construction right now.
yeah, these pictures are real. I mean,
Yeah, so hopefully you can go and have some wine very soon here in Spain.
I don't know where this is.
Sure, you're all invited to check if it works.
This is now.
It's now under construction. There were some extra challenges. I'm gonna make the questions myself, like here. So you see this building, the span of this upper cap, which is like a cap you use to protect yourself from sun. This is actually 5 meters, 20 meters, 2 meters. So we have to bust as a structure. So there's a big challenge to have all this water running around here, plus these tension cables that need to be stretched to support this thing up. So there's also a construction challenge. It's not the matter of the cost of these tubes, which are relatively cheap, but the fact of putting it there together all within both structures. So that's why I say that it's something holistic in that sense, because this has to be worked with 4 or 5 teams as a thing, hand by hand, right?
You have an estimation of the total budget for the company?
I do, but I don't know if I can. Yeah. But yes, it's gonna be pretty cheap actually.
Yeah.
Let's say that it's gonna be around 975 euros per square meter. So it's gonna be a very cheap building. 975 euros per square meter.
That's
more or
very
less.
accurate number.
It's pretty
It's not
accurate.
like that.
But more or less it's gonna be around that. So we're talking something, a standard installation of this type for a winery is around 700. So we're a little bit high, but in a reasonable
You
price.
compensate on the long term.
And you're saving a lot of money long term. So that's gonna be even,
Yeah, with these calculations, energy calculations, we are saving around 80% of the energy. If you
How many
compare.
circuits are there?
I don't remember because it's very big. This actually is like a football stadium size. So do you remember the number of circuits? It's a lot.
The circuits or what?
The number of circuits in the touch system. There's some of them, I don't remember.
I mean, we have 12 more holes.
No, system.
No.
You mean your systems in each of the slabs?
The circuits
Circuits.
of the
Ah,
pipes
yeah.
on the top.
Independent circuits, a lot.
Because it's very risky, something the tension and if a pipe.
Yes, actually, that's
break.
what. If you go to the slab slide, you see that it's very well divided, and even if one of the circuits break, you have enough number of circuits to make it to keep it together. But when you work this, you set the circuits in pressure, and when you're gonna pour the concrete on it, you're controlling all the time. So you have certain time to make a correction if there was a problem. Luckily, we did have no problem, and it's all the concrete poured and built, and structure is finished. So now we're happy on that. You need to be aware that no one drills a hole or something like that, but all of the construction control.
Mm.
So, thank you very much.
Thank you very much.